Good afternoon. Hello and welcome to this little video. I'm doing this video because I thought that some of you perhaps did not either have high school chemistry or have not had it recently enough to actually successfully complete one of the assignments for this week. That one specifically is, hold on just a second, it is this first discussion question we see right here. So this one, it's actually asking you to actually write a balanced chemical reaction. Well, you guys haven't gotten to that in lecture yet. And so I just wanted those of you who did not remember it from, like I said, high school chemistry or have never seen it before, to be able to complete this question. So what we're doing here is we're actually going to be comparing a theoretical value, essentially, for our compound against the experimental value you actually calculated in the lab. And so I'm going to show you how to do it. First off, how would we determine what a molar mass is of a compound just theoretically? So let me show you how you would do that. Chemical compounds often have, they have essentially element symbols such as, oh, wait just a second. All right, there we go. They have elemental symbols such as sodium or chlorine or something like that. You might have a chemical compound which would essentially be C4H. That'd be something like H10. Okay, so how would we actually calculate a theoretical molar mass for this particular thing? Well, you guys have talked about in class atomic masses or atomic weights for different elements. Basically, the way you do it for a molecule is like you add up all of the different atoms that molecule is composed of. So what does this little notation mean? This means it's made up of carbon and hydrogen atoms. The carbon, there are actually 4 carbon atoms in this molecule and 10 hydrogen atoms in this molecule. So how would we sum up the molar masses? It's actually pretty simple. We use the periodic table and the atomic weights on the periodic table. So let me switch over to a periodic table. Where is it? There it is. Let me move back to this. Alright, so we need carbon. If we look here on the periodic table on carbon, it says that carbon has an atomic weight of 12.0107. We don't need all of these sig figs, so I'm just going to abbreviate this a little bit. But we also see hydrogen over here at 1.00794. Again, I'm going to actually round that number just a little bit. So let's go back to our particular thing. So we essentially have carbon, which has a atomic weight of 12.01, but there are 4 of these carbons in this molecule, so we would want to multiply that by 4. And if we do that, we end up with, I believe it's 48.04. Now remember that we could use units on this thing. We could use AMU, which is atomic mass units, and that means that 4 carbon atoms, that's for 4 carbon atoms. They weigh 48.04 AMU. But the units we want are actually grams per mole. But those molar masses on the periodic table essentially tell us what the molar mass is of an element in grams per mole also. So we can just use the unit we want, grams per mole. Also, this could be written as grams over moles. Alright, so now we got that. We also need to have the hydrogens. Hydrogen has an atomic mass unit. So this is for hydrogen, this is for carbon. Of 1.01, again I'm rounding a bit. We have 10 of these, so if we multiply that by 10, that would be 10.10 grams per mole. Alright, so to find the total molar mass of this thing, we just add these 2 things together. That would be, let's see, let me do the math. There we go. I believe it would be 58.14 grams per mole. Okay, so that would be how we would find a theoretical molar mass if we knew what the formula of the molecule is. The formula meaning this thing right here. But we don't know what that is quite yet. So how will we determine that? Give me just a second. Well, what some of you might not have noticed, although it would have been a good thing to do, is the tablets that we were using this past week were actually Alka-Seltzer tablets. Now, Alka-Seltzer has a compound in it, an active ingredient that is sodium bicarbonate. So what I want you to do is look up the chemical formula for sodium bicarbonate. You can Google it online, find out what it is, and what I'm going to do is I'm going to give you some chemical reactions that are very, very similar Okay, one of these is actually almost identical to the actual reaction that is going on. Okay, so these chemical reactions are found in table 9.3 of your textbook. Okay, so one of these possible reactions is this right here. Remember that we were using hydrochloric acid. This is the formula for hydrochloric acid. Okay, alright, so we got KS. K2S. Alright, this is aqueous. Alright, so we have these two different, and this is how a reaction looks like. We got these on the left of these two compounds are what are called reactants, and then we have the line like this that actually is called a reaction arrow. It's saying left-hand side of this reaction arrow is reactants, right-hand side of this reaction arrow is products. The other thing is, you'll notice that I've got these parentheses here with these little AQ on the inside. I know that doesn't look like a Q. Just squint your eyes a little bit. Okay, so it says AQ, that means they're aqueous. What we're looking for is something that is a gas, because that's what we generated. Alright, so the reaction for these two chemical compounds coming together would be this right here. H2S, gas, plus 2KCl, aqueous. Alright. So you see when we mix these two things together, this one's called hydrochloric acid, this one's something else. I'm not going to name it yet because I want you to look up sodium bicarbonate. Alright, what this does is it actually forms this thing that's called dihydrogen sulfide. Okay, so it's two hydrogens and one sulfur atom just mashed together. This thing is a gas phase. Okay, so this is one of the possible reactions, again, that this could be. And remember that I'm not going to give you the exact reaction, but just one that's very, very similar. So is it one based upon what you find out this chemical compound's formula is? Why is that erasing? There we go. Or is it reaction 2? So 2HCl, and again aqueous, plus K2CO3, aqueous, going to form H2O, liquid, plus CO2, gas, plus 2K. Here, let me write it down here. Alright, so we got plus 2KCl. Okay, so we've got that that reaction right there. And then finally, I'll give you a third possibility that this reaction could be very much like. We have 2HCl. Again, realize I'm giving you hydrochloric acid in each of these cases. Oh, this is aqueous too. Plus K2SO3, aqueous, going to form H2O, liquid, plus SO2, gas, plus, one more thing, 2KCl, aqueous. Okay, so which of these things essentially is most like sodium bicarbonate? And then what I want you to do is rearrange sodium bicarbonate to essentially have the same gas come out. One of these gases in here is correct. Figure out which one is the likely one. Try to write down that chemical equation. And once you've done that, let's say for instance the gas was SO2 gas, okay? You would want to calculate the molar mass for SO2 gas and compare it to your experimental value. Okay, so the gas that you think is most likely based upon the fact that you are using sodium bicarbonate and hydrochloric acid as your reactants. Figure out what that gas is and then compare it with this equation that's called the percent error. Okay, and the percent error is found essentially in the journal, experimental packet right here. So you take your experimental value, this is the value you calculate, subtract off that theoretical value you get from the atomic weights on the periodic table, and then divide it by the theoretical value and multiply it by 100%. That is what I want you to do for this first discussion question. Again, I want you to show your calculations, but also write what are those calculations indicating? How did you decide which gas was the gas you generated? And how close was your experimental value to the gas you figured it should be based on the fact that it was using sodium bicarbonate? I hope this helps you complete this discussion question if you haven't already done this, if you needed this extra bit of help. And don't forget to complete this assignment, which is due next week, okay? Because don't complete the assignment, it's hard for me to give you credit for things not in. All right. Have a good time. Talk to you next week.